He's getting like AirPods. Is that like the gift of the year? AirPods is like the big thing right now. Oh yeah. Is that just? Did they just release that? Because I never even heard of that one. I thought they still had the 4. Are people getting like the new cell phone? What is it now? The 12? Or yeah, I have the 10. I decided to get a loopy case and got the wrong size. So that didn't work out for me. Okay. For my kids, we got the balance bikes. Have y'all seen those? No, y'all ain't got kids? Yes. Well, the balance bikes, remember like when you were little, you got your first bike, it had pedals, training wheels, all of that. Okay. Well, now for kids, they've come up with this thing called a balance bike, which is basically a bicycle that doesn't have pedals. So my twins are almost 2. So they're walking and running really good, but they don't have the coordination to pedal, right? But they can still ride their bike with Lily Jo. She's almost 4. She can pedal. So Lily has a normal bike. Now they're going to have their little balance bikes, and it's basically like a scooter that you sit on. So it's got like a little seat for them to sit on, but they can just like run their little legs. And so they'll like get to run and then they'll pick their feet up and glide. It's kind of like a glider. So that's what's popular with the babies right now, just in case anybody, needs to buy for a 2-year-old. So I'm excited. I love Christmas time. It's so fun. Do y'all still go look at Christmas lights? Do y'all drive around? I do. I love it. They have like a Shreveport like list of like all the good houses that you can hit up. So we're going to do that too. And then I don't know if you and your friends want to go for a drive, but there's a free drive-through in Longview called Camilla's, and it is really pretty. So if you like Christmas lights, you go. It's you could look it up. It's in Longview, so it's not that far away. But you turn your radio on, and it's playing Christmas music, and the lights. It's like a 20-minute drive-through. Like you'll drive through, and the lights all go to the Christmas music. So it's really cool. We did that with the girls when we were on quarantine because we didn't have to get out. We could just sit in our car. So that was fun. So there's so many fun things to do at Christmas time. So anyways, oh yeah, we went to the Rose Garden. Have y'all ever gone to the Rose Garden? That was cool too, and that's really close. Yeah. It's off of the interstate, I-20, toward Greenwood. Y'all should do that with your friends. It would be a fun, like, Instagram, go take pictures kind of place, because you just walk around, and they've got all the lights everywhere. It's pretty fun. You should do that, too. There's a lot of fun things to do right now. I know sometimes Shreveport feels like it's so boring. There's nothing to do, but there are some fun things to do, and that was cheap, so we're all about cheap things at my house. Okay, let's make sure I got this going right. Make sure I'm powered on so I don't have to. Okay, cool. We should be good. I think they can hear me. Can they hear me? Hello, hello, hello? I think so. Yeah, okay, we're good. All right, so on our bell ringer for today, it says on the XY graph, 3 corners of a parallelogram are located at those 3 points. Which of the following could be the remaining corner? Okay, what did you do to answer this question out? Did you draw it? You tried to graph it? Okay, let's see if I can try to graph it too. I feel like that's probably what most of us would do. The other option is to like do the slope. But I'll start this way and then we'll go from here. Now, look, if I was taking the ACT, okay, I wouldn't draw this like hoopty graph myself, okay? What I would do is I would go to the page before or either the page after and borrow a graph. There are going to be graphs on the ACT. Like you're going to have a graph somewhere on there. So just go flip the page, borrow that graph, and then you can plot it out on the actual graph. Because like you can already tell, like look how much I gapped from 0 to 1 right here. So you know it's going to be off because I'm drawing it by my hand. But if I could flip the page, you know your test has like pages of math, you know, you could just flip back or forth and you're going to see a graph somewhere. So just borrow the graph instead of having to draw your own. That's a helpful hint. Just so it can be, like, I'm trying my best to make it even, but you can tell I've already messed up. So plot those points. 3, 3 is there. And then we've got +4, -4. Then we have -2, -1. And we're missing the other point. So what you could do is look at your answer choices and kind of plot those out and see which one is going to give you a parallelogram. In order to be a parallelogram, you have to have 2 sets of parallel lines. This is actually what I'm doing with my geometry students right now. We're talking about parallelograms. So let's check this out. 8, 0. So this is 4, 5, 6, 7, 8. Do you think 8, 0 might be a possibility? Yeah, it looks pretty good. 8, -1 would be here. What do you think about that one? It doesn't look as good to me as 8, 0 does. Then you've got -1, +9, 3, 4, 5, 6, 7, 8, 9. So ignore this one. Could that be a parallelogram? Doesn't look like it to me. Then we've got -3, +6. 1, 2, 3, 4, 5, 6. So ignore those. Could that be one? That's pretty close, maybe. So that's a maybe. And then -5, +7. 1, 2, 3, 4, 5, 6, 7. I don't think that one's a no. So I think the 2 that we have to pick from are really A and D. So now, how are we going to prove A and D? How are we going to figure out which one it is? That's what we're learning in geometry right now, is to look at the slopes and compare the slopes of your different sets. So we'll start with this set and this set. We'll do 8, 0. So we're going to find the slope of those 2 sets. Remember, to find the slope, you're doing y2 minus y1 all over x2 minus x1. Okay, so for this one, y2 is -4 minus 3, and then your x's is 4 minus 3. So this is going to be -7 over 1, which is just -7. Okay. Hey, Christian, you did check in. Okay, cool. And then for this one, we've got 0 minus -1, so that's +1. And then you have 8 minus -2, so that's going to be 1/10. Do those have the same slopes? No. Okay, so that means this one can't be it, because they would have to have the same slopes, and those don't. So now let's check 3, 6. So I've already found the slope of this one. So now I need to find the slope of -3, 6 and see if they have the slope of -7. So I've got 6 minus -1. That does give us +7. And on the bottom, I've got -3 minus -2. So that's +2. So that is going to be 7 over -1, which is -7. Now, does that guarantee that this is a parallelogram? Well, it guarantees that these 2 are parallel, but you also have to have the other set parallel. So like if we know this is A, B, C, and D, and we have our parallelogram, A, B, C, and D, okay? What we've found out is that AB, segment AB, is parallel to segment CD. So top and bottom are parallel. But you can't just say that it's a parallelogram based on those 2 sides. We also have to look at AD and BC and compare those. So A is at 3, 3, and D is at -3, 6. Looks like 3 is Pinocchio. So now we're doing the other set. Okay, so I'm going to do the same thing though. My y's are going to be 6 minus 3, and then my x's are -3 minus 3. So that is going to be 3 over -6, which is -1/2. So the slope of AD is -1/2. And now we need to do the slope over here of BC. So B is at 4, -4, and C is at -2, -1. So you do your y's, -1 minus -4, and you do your x's, -2 minus 4. So on top, that gives me +3. On bottom is -6. That gives you -1/2. So this is -1/2, and that is -1/2. So that means they are parallel. So do we have a parallelogram? And the answer is D. So using your visual, plotting the points, that was very helpful. You would not want to do what we just did for all 5 of those. That would take you way too long. You don't have that much time on the ACT. Okay, so plotting them out to kind of get a good idea is where you would start. And sometimes, you guys, it's obvious. You're like, this is the only one that it could be. Circle it and move on. Okay, with this one, we had 2 that were kind of questionable. So that's why we had to do a little bit of math. Okay, but parallelograms have parallel slopes, which means that they are going to be the same slope with your opposite sides. Okay, all right, so that's your ACT for the day. Now we are going to go back into our book and finish up lesson 9. So we are on lesson 9. And our homework was on page 143. Let's definitely start there. I'm going to give you the answers for that homework. We can go over those if you need to. So go to page 143 to start. Page 143 is where we're starting. And then we'll go to page 144. Is anybody like got their module Canvas pulled up? Do we have a quiz this week? No? Okay. Then it's next week. So we are going, it's like, and I think I'm probably going to just make it a test. Okay. So it's going to be 100 points and kind of end us for the whole semester. So we'll not really, because we're not done with the semester, just kind of the break before we go to Christmas break. So I want to test you over everything that we've done prior to Christmas break, because when you guys come back from Christmas break, you are not going to remember anything that I taught you. Well, I hope that you will, but we'll see. Well, that didn't work. Okay, perfect. All right, almost there. Okay, so on last night's homework, you guys got that submitted, right? We're still getting our homework submitted, all of that stuff through Canvas. So on number 8, page 143, number 8, A's answer was x equals -3. So you just had one solution to that. It's just -3. You did it right. You just need to simplify. Just divide. Okay. So like I'm looking at Katie's because I can see hers, and she did hers right. She has 6 plus or minus 0 divided by 2, right? Okay. So if that's what you got, then you did this right as well. But 6 plus or minus 0 is still going to just be 6. 6 plus 0, 6. 6 minus 0, 6. So that's going to be 6 over 2. 6 over 2 simplifies to give you 3. So that's why there's just one solution. So if you did, wait, what? I don't know. It's -3. Did you? Yeah, you got -6. So she has a -6. So it's -3. Yes. You wrote -3 twice. It really, and honestly, you're right because it's a double root, like, but you only need to write it once. So if it's the same number, just write it one time. But if it's different numbers, then write both of them. Or if it ends up with a plus or minus, then you have the 2 answers. So really, the only time you won't have 2 answers is if it's the same number. Okay, B. B's answer is x equals -5 plus or minus the square root of 217 all over 16. Did you get that? Some of you are nodding. Yay. It's awesome. Okay, C, your answers are -10 and +2. And with that one, you guys, I would have just isolated x. I would have added 36, then taken the square root of that. Did you guys do it that way? You want me to show you that? What I would have done for that one, whoops, sorry. Okay. So what I would have done for this problem C is I would not have done the quadratic formula just because of the way they wrote this. So in order for you to do the quadratic formula, it has to be in standard form. Well, that's obviously not in standard form. It has parentheses. So what I would have done is I would have just tried to solve for x. Since it's not squared, I can get to that x undoing everything. So I would have added 36. So that would give you x plus 4 in parentheses squared equals 36. How do you get rid of the square? Take the square root. So you got x plus 4 equals plus or minus the square root of 36. Well, what do you know about the square root of 36? It's perfect. So x plus 4 equals plus or minus 6. Then we subtract 4. X equals -4 plus or minus 6. So this is one that you could split up. So if you got to that, you did this right, but those are both 2 normal numbers. So since they're both normal, you can do -4 plus 6 and -4 minus 6. So instead of leaving it as plus or minus, you split it up. Then that's going to give you +2, and this one's going to give you -10. I feel like that's the easiest way to do that problem. Way easier than doing the quadratic formula. Okay, and then for the last one, D, your answer was, I'm just going to write it so it's easier to see, -1 plus or minus 2 square roots of 2. So that's definitely been simplified. So you did yours right too. You just need to simplify that 8. Does anybody need help seeing that simplified? Okay. Because it looks like y'all are doing it right. It may just be the simplifying part that's getting you guys. Okay, so with D, this one, you need to, first of all, make it equal 0. Has to equal 0 first. You can't do anything until it equals 0. So I'm going to subtract 7. x squared plus 2x minus 7 equals 0. Now you're ready to go. So A equals 1, B equals 2, C equals negative 7. Once you have all that done, then you just simply put x equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. I feel like you guys are okay on this. That's why I'm kind of going quickly. I feel like you got this part. What's underneath that radical? What is it? 32 over 2. Okay, so if you got to this part, you're doing everything right. You're doing good. You're on track. This is where we have to simplify. So that square root of 32 has a perfect square in it. This is where you messed up. You can use 4. 4 times 8. But 8 also has a perfect square in it. So then you'd have to do it twice. Well, you don't want to do anything twice. So what's another perfect square that's within 32? Not 4. It's not big enough. 16. So 16 times 2 gives you 32. The square root of 16 is 4. And the square root of 2 stays in the house. So that's how you would have done that. And then you have negative 2 plus or minus 4 square roots of 2 over 2. The 4 you are going to in just a second, but not yet, because the square root of 16 is 4, so you don't change it yet. Okay, because all I did was just rewrite it. Now that you have it all there together, you can see the numbers on the outside. Never go into the house. Never go into the house. But those numbers on the outside are all divisible by what? By 2. So that's how you can simplify it. Negative 2 divided by 2 is negative 1. 4 divided by 2 is 2. You cannot touch what's in the house. And then on the bottom, 2 divided by 2 is 1, which you don't need that 1 on the bottom, but you do need this one. You've got to keep that one there. So negative 1 plus or minus, I forgot my minus, 2 square roots of 2. But I want you to know that if you're able to get like to this part right here, that means you're doing it right. You are doing the process correct. You just are having trouble simplifying, which simplifying is the hardest part. Okay? All right, so that was that homework. Now we're going to flip the page. Sure. We're going to go to page 144. David, where is your textbook? Put your computer up. You do not need your computer in my class ever. Your grandmother is right next door, and she would literally kill you if she knew you were not paying attention. She will kill you. David, if I go next door and say, David is not paying attention to me, she will kill you. She will kill you. Don't. Okay. Okay. All right. So this lesson stems from the last lesson. Okay. So last lesson was all about the quadratic formula. And Zariah asked a good question. And today I'm going to be able to tell you how you're going to know. She wanted to know, how do you know when you only have one answer, or when you have, well, that's what she asked, but how do you know if you're going to have imaginary solutions or real solutions? How do you know? Well, the discriminant is what allows us to know, okay? And sometimes your test or the ACT or whatever will just straight up say, how many solutions does this have? Well, you don't want to have to go through the process of doing the whole solving, doing all of the quadratic formula to figure that out. You don't have to do that if you know the discriminant. So this lesson tells us to solve quadratic equations with the quadratic formula. We already know how to do that. We got that. The next thing we're going to do is use the discriminant to determine the nature of the solutions. So our options for solutions are 1, real solution. We saw that on our homework. Okay, on your homework, the answer was just -3. It had one solution, okay? We call that a double root, okay? What that means is it basically sits on the x-axis. So here's our x-axis. It just sits and pops right back off. So that's supposed to look like a curve, not a V. It's a curved line. The next option is to have two real solutions. If you're going to have two real solutions, it's going to cross the x-axis twice and have two real solutions. The third option is to have two imaginary solutions. And if you have two imaginary solutions, that means your parabola does not physically touch the x-axis. It's like a floating parabola. It's up there kind of floating around. So you'll have two imaginary solutions. Now, you're going to be able to make that determination based on something called a discriminant. Well, the discriminant is part of the quadratic formula. So remember, the quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. So we've got the quadratic formula. We've heard the song. We know that. We know who to plug in. Your discriminant is right here. It does not include the radical. It's just b squared minus 4ac. b squared minus 4ac is your discriminant. That is going to determine how many solutions. Okay, so I think there is. Go to page 146. All right, so on page 146, okay, you're seeing what I'm telling you, the discriminant, okay? That's how you spell it. That's what it means. It's from standard form. Again, if they ask you what the solutions are or ask for the discriminant, it must be in standard form. Then, once it's in standard form, it's b squared minus 4ac. It's what is underneath the radical. And then this is your options. If the discriminant is greater than 0. What does it mean to be greater than 0? Not a negative, so positive. If your answer is positive, it could be any positive number. It could be 3, 36, 480. Any positive number, you are going to get two real rational solutions. And sketch out beside that it crossing twice. Just a little sketch so you know exactly what that means, or somewhere close to it. So positive number means we're getting two real rational roots. Now, that is if it is a perfect square. So perfect square being like 4, 16, 9, 25, 49, all of those. You're still, if it's positive and not a perfect square, so still positive, it's just going to be irrational, which means it will be at a decimal or a fraction. But it's still going to physically cross 2 times. So the first two are really linked together. Those are all your positives. Any positive number is going to give you two real roots. It's rational if it's a perfect square. It's irrational if it's not a perfect square. Now, this one just straight up equals 0. So just equals 0. If you plug it in and you get 0, then you know you only have one rational root, which is what we call a double root. That's where it just sits on the x-axis. Yes, David. Hold on. This is important. Let me finish this chart. Okay, so that's 1. If it equals 0, you're going to have 1 root. It sits right there on the x-axis. This is if your discriminant is less than 0. What kind of numbers are less than 0? Negative. So any number that you get that's going to be negative, that gives you 2 complex conjugate solutions, which is just a fancy way to say imaginary, which means your parabola is floating. It doesn't actually touch the x-axis. Now, David, you can go once you get that done. So over here to the side, they give you the definition of a discriminant. This says a solution to the equation is also called a root. Remember, we talked about that. ACT will say all of those things. Solutions, roots, x-intercepts. All of those things mean where it's going to cross the x-axis. This says the roots of the quadratic equation, ax squared plus bx plus c equals 0, the zeros or x-intercepts of the quadratic formula. So that's the other things that you can call it. Zeros, x-intercepts, or even solution. Those are the 4 words. So let's look at number 7. The first thing you have to ask yourself every single time, Lily, Gracie, y'all put your phones up. If we're looking at this, the first thing that I need to know is this in standard form? Is it? Yeah, ax squared plus bx plus c. So we're good. It's in standard form. So then, just like with the last lesson, you're going to identify A, B, and C. Just like we did before, identify those. So who's A? 4. Who's B? And who's C? -6. So 4, 5, and -6. And then we don't have to do the whole thing, you guys. I don't need the whole quadratic formula. The only thing I need is b squared minus 4ac. That's going to give me everything that I need to know. If it's positive, if it equals 0, or if it's negative, I'm going to know what I need to know. So who's B? 5, and I always put that one in parentheses just out of habit to make sure I don't mess it up. Who's A? 4. And who's C? So you're just plugging those in. Then if you've got yourself a fancy little calculator or just any kind of calculator, you can literally just type that whole thing in your calculator and bam, it will give you your answer. If not, then you're going to have to kind of do the math as you go and work this out. What's 5 squared? 25. Then we've got -4 times 4. What's that going to be? That's going to be -16. Now we have to multiply -16 times -6. What's that going to be? What is it? 96. So positive 96. So then we have 25 plus 96. What's that going to be? 121. So your discriminant is 121. Is it positive, 0, or negative? Positive, which means it has to be one of the top 2. So the second question is it a perfect square or is it not a perfect square? What's the square root of 121? 11. So it is a perfect square. So that means we are going to have 2 real rational roots. That's what you're doing. You identify A, B, and C. You do the math real quick, then you decide. Is it real, imaginary, what? Let's do B. Okay, so for B, who's A? Who is, I'm sorry, yeah, A is 4. Who's B? And who's C? So again, you're just plugging that in. B squared minus 4AC. B is still 5 minus 4 times A, which is 4, times C, which is negative 2. Okay, everything's pretty much the same. This is going to be 25. Negative 16 times negative 2. That's going to be 25 plus 32. What's 25 plus 32? So is 57 positive, 0, or negative? Positive. Is 57 a perfect square or not? So that means it's going to be 2 real irrational. Yes. Yes, yes, yes. I'm saying roots, but it says solutions, and I don't, if you say solutions, Lily, that's fine with me. They're the same thing. Okay, so 4x squared, I'm going to do C up here, plus 4x plus 1 equals 0. A is 4, B is 4, C is 1. B squared is going to be 4 squared minus 4 times A, which is 4, times C, which is 1. Okay, so you've got 4 squared, which is 16. Negative 4 times 4 is negative 16 times 1 is negative 16. What's 16 minus 16? How many solutions do we have? One real, is it rational? Yep. One real rational root or solution or whatever you're comfortable with. And what do you think the last one's going to be? It'll be negative, which means it would be 2 complex conjugate, or you can just say 2 imaginary. So what do you need to do? Flip the page. On page 148, don't read the instructions for number 13. All I want is to know, just like what we just did, how many solutions are they going to have? You do not have to do the quadratic formula. You don't have to give me the exact solutions. I want you to do exactly what I just did and pick from the chart and tell me about those solutions. So you're doing page 148, number 13, all 6 of those. $148.